Hey guys, it's Sid the Magician, and today I will be going over the formal definition of a limit, also called the epsilon delta definition of a limit. Take this function, for example. You know that the limit of f of x as x power to c equals a real number L, and there's a hole here, but the limits from the left and right side both equal L. We can pick an interval between c minus delta to c plus delta. We plug it in, and it would guaranteed be in the range of L minus epsilon to L plus epsilon. And a neat way of saying this was the definition. Let f be a function defined on an open interval containing c, except possibly at c, and let L be a real number. The statement, limit of f of x as x approaches c equals L, means that for each epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than x minus c is less than delta, then f of absolute value of f of x minus L is less than epsilon. Basically saying that in the range, there should be a delta there should always be a delta for a given range of an epsilon. Okay? F of x minus L. So the difference between the actual true value of L and f of x would be less than epsilon. Basically, the difference will always be within an epsilon. So I already went through one type of question on this, finding a delta for a given epsilon. So if we were given the epsilon of what? 0.01. We want to be within 0.01. Okay? We have the limit of 2x minus 5 as x approaches 3 equals 1. Now, we know that it's between 0, x minus c, or c is 3. So 0, x minus 3, and delta. We know f of x minus L, epsilon. So actually, I wrote epsilon here, but I could just write 0.01. Okay, we have to make the 2x minus 5 minus 1 turn into x minus 3. Okay, so we can find the delta. Well, that's pretty easy to do because 2x minus 5 minus 1 is just 2x minus 6. Factor out the 2. Okay, divide the 2 out, and you get 0.01 divided by 2, or 0.005. So we just shown that x minus 3 has to be between 0 and 0.005. 0.005 is the delta, and 0.01 is the given epsilon. And another way, and just like a final way to prove this, is basically with the f of x minus L. F of x minus L has to be less than epsilon. So a nice way to do this would be, if you have 2x minus 5 minus 1, so f of x minus L is less than epsilon, we have 2x minus 6. So this will be 2x minus 6, which will also equal 2 times x minus 3, right? And what was x minus 3 between? 0 and 0.005. So you just got to multiply 0.005 by 2. So 2 times 0.005, and you get 0.01. So we just shown that our L will be between 0.01. The L will be within 0.01, and the C will be within 0.005. Now, not where we're given finding a delta for a given epsilon, but let's do one where we just have to use the definition of that limit. So, for example, we'll do limit as x approaches 2 of 3x minus 2 equals 4. So, L is 4, C is 2. This is our f of x. Now, we know the first thing, 0, x minus, c would be 2, and delta would be here. And we're not given anything this time. We're just using the definition, meaning we won't get a number here. We won't get 0.01. We'll get epsilon instead. But epsilon is 0.01, but this time we won't be given one, like a value. But that's okay. We just got to show that this is true, and then we can prove the limit. So, this is the first thing, and then f of x minus L. So 3x minus 2 minus L less than epsilon. Perfect. Now, we got to manipulate this to look more like this, right? So this would be 3x minus 6 is less than epsilon, and then factor out the 3. And now divide by 3, and you would get x minus 2 is greater than 0, but less than epsilon over 3. Now we just shown that delta is equal to epsilon over 3. So we can kind of choose any epsilon, and we can choose a delta that's just divided by 3. Same way you can, most people care about the limit more, not the c value, the c range. So the delta is only found out from the epsilon, but you could do the same thing. Epsilon equals 3 times delta. So now we just got to prove this last thing right here, f of x minus L is less than epsilon, which is fairly easy. To do this, it's kind of the reverse of what we just did. We have 3x minus 2 minus 4, okay? Now, this equals 3x minus 6. Factor out the 3 times x minus 6. Now, guess what? What was x minus, sorry, it's going to be x minus 2 here. My bad. No. 6 here, but 2 here. Okay, what was x minus 2 between? 0 and epsilon over 3. So, 3 is here, multiplied by this x minus 2 part, which is just epsilon over 3. So 3 times epsilon over 3. The 3's cancel out, and we've got epsilon. Basically, we proved this. F of x minus L is less than epsilon. That was one example. We'll do one more example, and that's it. So let's do limit of x squared as x approaches 2 equals 4. Now, same thing. First thing, 0 is between x minus 2, and we have delta. And now, f of x minus L. So we got x squared minus L is less than epsilon. Now, for this is also pretty simple because x squared minus 4 is just x plus 2 times x minus 2. So we can just split this as x plus 2, x minus 2, less than epsilon. Now, the thing about this is, since x is between 1 and 3, and we need to isolate x minus 2, okay? So we have to get rid of this x plus 2. An easy way to do that is in the range of 1 to 3, because that's pretty close to 2. What would be the max of x plus 2? 3 plus 2 is 5. So what I'm trying to say is x plus 2 would be less than 5 on 1 to 3. So we can just say this is less than 5, and now guess what we have? Absolute value of x minus 2 is less than epsilon over 5. This is a 5, I just divided it over. Now, we have the first part. Delta equals epsilon over 5. Now, we just have to prove the last part. The f of x minus L is less than epsilon. So, we do f of x, which is going to be x squared minus L. Now, for this, what does this equal? X plus 2 times x minus 2, correct? Plus 2, x minus 2. And now, this is fairly easy. X minus 2 is less than delta, or less than epsilon over 5. And x plus 2 is less than 5. So this is literally just 5. So we can say x plus 2 times x minus 2 is less than, x plus 2 is 5, and x minus 2 is epsilon over 5. 5 times epsilon over 5, 5's cancel out, equals epsilon. So we just proved that f of x minus L is less than epsilon. So that's it for this video. We just did 2-3 examples on showing you can choose a delta and an epsilon so that in the range of c minus delta to c plus delta, wherever you plug in to f of x, you will get a value that's in the range of L minus epsilon and L plus epsilon. Thank you for watching.